Hello students, very good morning to all. Myself, Mr. Nitin Sasane, working as an assistant professor, Department of Chemistry, Mahatma Phule Arts, Science and Commerce College, Panvel. Today, we are going to discuss about the heterocyclic compounds 1. Now, in heterocyclic compounds 1, there is a very important topic, that is azole family. Azole. Yes or no? Azole. So when I said azole, Az stands for nitrogen, and azoles are the heterocyclic compounds which are 5-membered heterocyclic compounds containing 2 heteroatoms, that is nitrogen, at position number 1 and 3. Therefore, these compounds are called as 1,3-azole. Okay. Now look at here. Benzimidazole, thiazole and oxazole are the 3 examples of 1,3-azole. Okay. So when we look at the structure of this azole carefully, it is clear that position number 1 contains nitrogen. In case of thiazole, heteroatom is sulfur. In case of oxazole, heteroatom is oxygen. And in these compounds, position number 3 is compulsory occupied by nitrogen. Okay. Look at here. Position number 3 is occupied by nitrogen. Okay. So this is the position number 1 is the position of heteroatom, and position number 3 is compulsory occupied by nitrogen. So in these compounds, 2 heteroatoms are present at position number 1 and 3. Therefore, these compounds are called as 1,3-azole compounds. Okay. Now, when this 5-membered moiety is attached to benzene ring, the new heterocyclic compounds, the structure of new heterocyclic compounds is generated, and that compounds are called as benzo 1,3-azoles. Okay. So benzo stands for benzene. Look at here. This is the benzene, and benzene ring is fused with 5-membered heterocyclic ring. Here imidazole, therefore it is called as benzimidazole. Again benzene, and it is fused with thiazole, therefore it is called as benzothiazole. Now benzene fused with oxazole, therefore it is called as benzoxazole. Dear students, azole family is very important family in the heterocyclic compounds. And in front of you, there are 6 compounds which belongs to class azole. 3 are simple azoles. Examples are imidazole, thiazole and oxazole. And remaining 3 are when these compounds are fused with benzene, they are called as benzoazole, benzimidazole, benzthiazole and benzoxazole. Okay. Next. Now similarly 1,2-azole compounds are also present in heterocyclic chemistry, and benzo 1,2-azole compounds are also present in heterocyclic chemistry. So what is 1,2-azole? Again, 1,2-azoles are the 5-membered heterocyclic compounds which contain 2 heteroatoms. One is present at position number 1. Okay. And similarly, heteroatom, that is nitrogen, is compulsory present at position number 2. Look at here. This is the position number 2 which is occupied by nitrogen. Position number 2 is occupied by nitrogen, and position number 2 is occupied by nitrogen. So when we are going to study the azole family, it is very clear that azoles are classified in 2 classes. First one is benzo 1,3-azole, and another one is benzo 1,2-azole. Okay. Now 3 compounds are present in benzo 1,2-azoles. Look at here. First one is pyrazole. Second one is isothiazole, and third one is isoxazole. Okay. Similarly, when benzene fused with pyrazole, it is called as indazole. When benzene fused with thiazole, it is called as benzothiazole, and when benzene is fused with isoxazole, it is called as benzisoxazole. So once again I repeat the examples of 1,3-azole and the examples of 1,2-azole. Okay, wait. Okay, so these are the examples of benzo 1,2-azole, pyrazole, isothiazole and isoxazole. Similarly, these are the three examples of benzo 1,3-azole, imidazole, thiazole and oxazole. Okay. Now, once you understand what is azole compounds, next important class, 1,3-azole examples are imidazole, thiazole and oxazole. Their reactions and their synthesis. So as I told you earlier, there are three important examples of benzo. There are three examples of 1,3-azole. First one is imidazole, second one is thiazole and third one is oxazole. Okay. Now we are going to start the discussion on their reactions and synthesis. Now this is the very important slide which shows what is the influences on the positional relativities of 1,3-azole towards electrophilic substitution. Now look at here, this Z stands for our main heteroatom, which may be nitrogen, which may be sulfur or which may be oxygen. Okay, and as I told you earlier, position number 3 is compulsory occupied by nitrogen. So this is the general structure of azole, 1,3-azole. Okay, now consider this is position number 1, this is 2, this is 3, this is 4 and this is 5. Now position number 2 is most strongly deactivated position, like pyridine alpha position. Okay, so why this position number 2 is strongly deactivated? The reason is, from one side it is attached to nitrogen and from another side it is attached to another heteroatom, and we know that heteroatoms are electron withdrawing. Therefore position number 2 is strongly deactivated. Now position number 4 is deactivated by inductive withdrawal of the adjacent nitrogen. Okay, and position number 5 is least strongly deactivated. So when we look at the structure of this 1,3-azole, general structure of 1,3-azole carefully, it is very clear from the structure that position number 2 is strongly deactivated, position number 5 is least deactivated, and position number 4 is in between position number 2 and 5. Okay. Now these are some typical reactions of 1,3-azole. Okay, these are the typical reactions of 1,3-azole. This is the general structure of 1,3-azole, and look at here, electrophilic substitution basically takes place at position number 5. Okay. Now what are the examples of electrophilic substitution reactions? The first one is nitration, second one is sulfonation, third one is halogenation. All these are electrophilic substitution reactions, and in case of 1,3-azole, electrophilic substitution reaction basically takes place at position number 5. Now besides this, these 1,3-azole compounds, they undergo cycloaddition reaction like dialside reaction, and it gives the product cyclic adduct. Okay. Now third important reaction, this 1,3-azole react with methyl iodide and methylation takes place at imine nitrogen. Now look at here, this imine nitrogen get methylated. Are you getting? Now protonation takes place at imine nitrogen. Look at here. Fourth reaction is protonation. After protonation, regioselective 2-lithiation takes place. Means the meaning is lithiation takes place at position number 2. And last reaction, when we treat this 1,3-azole with base withdraw this hydrogen and there is the formation of imidazolyl anion, and once this imidazolyl anion is formed, electrophilic substitution takes place at this position number 1. So these are the typical reactions of 1,3-azole. Okay, 5 to 6 reactions are there. First one is electrophilic substitution. second one is cycloaddition, third one is methylation, next one is protonation, lithiation, and electrophilic substitution at imine nitrogen. Okay. Now similarly, this is the structure of 1,2-azole, and in case of 1,2-azole, position number 3 is more strongly deactivated. Okay. If you remember, in case of 1,3-azole, position number 4 is strongly deactivated. Okay. Okay. Now, again, these are the typical reactions of 1,2-azole. This is the general structure of 1,2-azole. And look at here, electrophilic substitution in case of 1,2-azole takes place at position number 4. Are you getting? Methylation takes place at position number 2. That is, imine nitrogen get methylated. Protonation again takes place at imine nitrogen. Lithiation takes place at position number 5. If you remember, in case of 1,3, lithiation takes place at position number 2. In case of 1,2, lithiation takes place at position number 5. Okay. And if this 1,2-azole treat with base, there is a formation of pyrazolyl anion. And when we treat this pyrazolyl anion with electrophile, then electrophilic reaction takes place at this nitrogen. Okay. So my previous slide and this slide indicate this is the summary of typical reactions of 1,3-azole and 1,2-azole. Okay. Thank you very much. In this lecture, we saw the typical reactions of 1,3-azole, typical reactions of 1,2-azole, examples of 1,3-azole, and examples of 1,2-azole. Thank you very much for watching this video.